Welcome back to the 38th part of Debugging at Scale, where we toggle the buttons until we can isolate the problematic area. Feature flags aren't specifically related to serverless debugging. I would recommend picking them up for a monolith too, perhaps even more so. I'm discussing them here since they are a great tool for lowering the risk of testing in production. In a serverless environment, these are one of the chief mitigating capabilities. With feature flags, we can dynamically enable or disable a feature. We can include it for a specific subset of our users or only for testing. This lets the general population work with code that was previously working. When adding a new feature, we can wrap the risky code in a check. Thanks to checks like this, we can dynamically check functionality in production and instantly revert a feature if it causes a regression. The core functionality of a feature flag is trivial. It can be something as simple as a lookup file or a database table, but that might not scale in a serverless or microservice environment where constraints might be more complex. Some feature flag tools support segmentation of users, which you can use to enable features only for beta testers and not the general population. This gets very complicated, especially when a feature crosses tiers. A great example is a feature that requires changes in multiple serverless environments and in client-side code. All the pieces might take a while to deploy separately. A feature flag can keep the feature hidden until all the pieces are deployed. Once deployed, we can enable the feature for testers, and it will activate on the client-side code as well as all the server logic. A less naive version of the feature flag code from before would pass more details to the API, so we can segment appropriately. This is what the Launch Darkly SaaS feature flag platform does. We can pass additional metadata to decide on the feature. Notice that data is cached locally, but it's also invalidated in case of changes from the server. When releasing serverless feature to production, we can stage the rollout. So a failure would be detectable. We can determine the percentage of requests that will receive the new code in Lambda. We can also use a canary, a segment that will receive the new code. For instance, a specific country only. This isn't ideal. We don't want an entire country to receive a failure, but it's better than a failure for all the users of the application. Sophisticated deployments such as these can be accomplished via an API gateway or via the serverless platform itself. Debugging serverless is a painful experience. Thankfully, there's a better way, which I didn't discuss here. It's through observability tools that I will cover in the final module. Even with these solutions in place, the process of debugging serverless deployments is painful. It's a regression and a serious throwback. It's the main reason I'm not a big fan of serverless deployments. When something fails, it can fail badly. A company can lose a significant amount of money due to resource hogging bug. In fact, such a thing happened to me in the days of past, and I was stuck in a situation where I had no way to debug the problem. To this day, I don't know which of my workarounds succeeded. I couldn't log properly since this would have increased our costs even further. It was a problematic environment, and I was debugging in the dark. This concludes our short serverless module. In the next video, we will discuss full-stack debugging, which will focus on front-end and a bit on database solutions. If you have any questions, please use the Slack channel to ask them. Thank you.